Solving equations with logarithms is what we're going to cover in this video. And we're going to do that with the properties of logarithms as well as also utilizing the one-to-one property, which a visual is given on the Google site page. So let's get started first of all by realizing that anytime that we're solving equations, we're asking the question, what will make the equation true? So we always have to consider domain restrictions when we're solving equations with logarithms. So let's get going. First of all, we get the opportunity here to utilize inverse operations. So since this is 2 times ln of 3x, the first thing I'm going to do is divide away the 2 and get ln of 3x equals 2. Now, please recall that ln simply means log base e. So let me rewrite this so you can get a better look at it. And then we are going to rewrite this logarithm as an exponential equation. So e to the second power equals 3x. E squared equals 3x. And then from here, we can very easily solve for x by using the multiplication property of equality, dividing both sides by 3. We get x equals e squared over 3. And this is the exact answer. And an exact answer is usually best. Only go to a decimal approximation if it is specifically requested. So, number 2. This is the common log, log base 10. If we don't see a base there, it's understood to be base 10. We're going to use the same strategy we just did on the previous problem. We're going to rewrite this as an exponential equation. 10 squared equals 3x plus 1. 10 squared, of course, is 100. 100 equals 3x plus 1, minus 1, minus 1. 99 equals 3x. X equals 33. And for both of these, if we go back here, think about this. E squared would be a positive number, and a positive number divided by 3 will be a positive number. So it is okay. It is perfectly good and fine for us to have a positive number going in there. Also, if we put in a 33 here, it makes sense. 3 times 33 is 99. 99 plus 1 is 100. 10 squared equals 100. So both of these check with no issues whatsoever. Next, we have logarithms on both sides. And this is a great example of log base 2 equals log base 2. This is a great example of the one-to-one property. One single logarithm is set equal to one single logarithm, and they both have the same base. So if this is true, all we have to do is set the arguments equal to each other. And very simply, we get x equals 50. We're going to utilize the same base in number 4, but first we need to make it have the same base. And what we're going to do here is realize that 27 is a power of 3. So we can make an equivalent substitution here. So we've got 3 to the 2x equals 3 to the third to the fourth. So now we have like bases. Use the power property from Algebra 1 and multiply those exponents together, and we get 3 to the 2x equals 3 to the 12th. Drop the bases by one-to-one property. 2x equals 12, x equals 6. That's 3, that's 4. Both of these are positive numbers, so that pretty much is a good thing as well. Number 5. Number 5. This is not a one-to-one comparison because this is a logarithm set equal to a whole number. So we've got to work on this one a little. Remember, ln means log base e. So log base e of x plus 3 cubed equals 4. So let's rewrite this in an exponential format, and we end up with e to the 4th equals x plus 3 cubed. So from here, we need to use inverse operations in order to isolate the variable x. So to do that, I am going to take the cube root of both sides. So, and it might be easier just to rewrite this as a fractional exponent. So instead of the cube root of e to the fourth, let's just let it be e to the 4/3 equals x plus 3. Then from there, e to the 4/3 minus 3 equals x. And that is a valid answer as well. Number 6, this is a sum. So we're going to use the product property of logarithms and put these two logarithms together. First, condensing that left-hand side, which gives us log base 2 of x times x minus 2 equals 3. So 2 to the third equals all of that. So 2 to the third equals, and I'll go ahead and I'll go ahead and multiply these together. X squared minus 2x. Then notice that this is quadratic, and that's why it was necessary to multiply them together. Because when we have a quadratic equation, we need to set equal to 0. So 0 equals x squared minus 2x, and of course 2 to the third is 8, minus 8. Now it's factorable. Factors of -8 that add up to -2 are x minus 4 and x plus 2. So x equals 4 and x equals -2. Now this has a domain issue here, a restricted value. If we look back at the original given problem, log base 2 of -2. Is there a power of 2 that is equal to -2? No. So that is going to exclude that answer. It's also not going to work here because -2 minus 2 would be -4, and there is no power of 2 that is equal to -4. So our only reasonable answer here is 4. That's why we have to take a look at restricted values. 2 more quick problems. So in this number 7, we need to condense the left-hand side. So we need to use the Superman rule and put that power back over. So log base 4 of x squared minus a log base 4 of x minus 1 equals 1. So because it is a minus, this is going to turn into a quotient. So log base 4 of x squared over x minus 1 equals 1. So now we're going to go from a logarithm back to an exponential equation. So 4 to the first equals the argument. So 4 to the first equals x squared over x minus 1. Now this turns into a nice little proportion that needs to be solved. And in order for us to do that, let's cross multiply. So x squared equals 4 times x minus 1. X squared equals 4x minus 4. And once again, because this is quadratic, let's set it equal to 0. So x squared minus 4x plus 4 equals 0. This is a perfect square trinomial that can easily be factored to x minus 2 times x minus 2. And of course, if x minus 2 times x minus 2 equals 0, then x is only 2. And that is a wonderful answer because it's positive. 4 to what power is 2? 4 to the 1/2 power is equal to 2. 2 minus 1 is 1. 4 to what power is equal to 1? 4 to the 0. So this is a valid answer. Last problem. Use some algebra here. This is 2 to the x times 2 to the 3x minus 1. We are multiplying and the bases are the same, so we're going to add the exponents together. 2 to the 4x minus 1 equals 16 to the x minus 2. So once again, we need a one-to-one comparison here. So we're going to replace 16 with 2 to the 4th power because 16 is a power of 2. So 2 to the 4x minus 1 equals 2 to the 4th raised to the x minus 2. So we've got to multiply those powers together, and we get 2 to the 4x minus 2 equals 2 to the 4x minus 8. Something looks a little fishy here, because now drop those bases because we have a 1-to-1 comparison, and we end up with 4x minus 1 equals 4x minus 8. So if 4x minus 1 equals 4x minus 8, and we drop the 4x's, we end up with negative 1 equals negative 8. Does that make sense? No, it does not. Therefore, there is no solution. So that is 8 beautiful examples of solving logarithmic equations using the properties of logarithms and also using the 1-to-1 property.